Start recording and let's go here. We're going to be talking about graphing on a number line, absolute value inequalities. All right, and it gets a little bit tricky. So if I have my number line, all right, and I have 4 right here. The absolute value of 4 is less than 4. So basically what you have to do is you have to say 2 different ways. I have to say x itself can be less than 4, but the opposite of x can also be less than 4. All right? Because the absolute value changes the sign when it's negative, correct? All right, so basically what I'm going to have to do is I'm going to have to put a graph of 4 and negative 4, and if the opposite of x is less than 4, well, let's do this one first. If x is less than 4 but not equal to 4, I have to put this in here and thicken the line this way. All right? But if the opposite of x, remember, if I multiply something times a negative, that means x is greater than a negative 4. So I have to put an open circle here and go this way. So in this scenario, x can be anything between negative 4 and positive 4. You follow me? All right, now this one over here, I also am going to say x can be greater than 7, but the opposite of x can be greater than 7. Well, what that means is x is going to have to be less than a negative 7. Well, if I have a positive 7 here as greater, it's going to go this way. And if I have a negative 7 here as greater, it's going to go this way. So instead of being everything that's in the middle here, it's everything on the sides, on the outside. All right? If I continue, I still do the same thing I would for any other equation over here. I would still go ahead and subtract 7.4 from each side. All right, so now I would have the absolute value of x is less than or equal to 2.4. Follow me?
Yeah.
Okay, and so then I still have my 2 different scenarios I have to watch out for. X can be less than or equal to 2.4, but x also can be greater than, or x can also be greater than 4. And you see how I skipped a step there?
Yeah.
See how I skipped a step there? And so if I was going to graph that, all right, if I was going to graph that, I would have negative, I would have 4. And a solid dot because it's greater than later. And another dot at 2.4 and a solid circle. You can't equal it, so it's getting smaller. All right, so that's how you deal with absolute value inequalities. Deal with absolute inequalities. Let's look at this one right here. You're going to do the same thing you would normally do. Over here, I would multiply each side times 4. I end up with absolute value of x is greater than 8. Greater than 8. And you go through the same process that you would over there. I'm going to not do any more of that one. All right? Do any more of that one over here. All right? So I have to divide by a negative 2 here, don't I? Is that going to change this sign right here?
Vela, turn off your microphone. It's causing his voice to go staticky.
Yeah, let's keep the microphone off until you have something to say. All right? So if I divide each side by a negative 2, I'm going to get absolute value of x, and it's going to flip that sign is now greater than a positive 3, because a negative 6 divided by a negative 2 is a positive 3. And again, that gives me two scenarios. X either has to be greater than 3, or the opposite of x is greater than 3, which means x is going to be less than a negative 3. And so in order to graph these two things, I'm going to have my number line, and I'll have 3, and I'll have negative 3, and I can put a 0 here if I want. All right? And so if x is bigger than 3, open circle, arrow going this way, and x is less than negative 3, open circle going that way. What gets tricky, however, is when you have stuff that's inside, that's where it gets tricky, all right? And you have to go about it the same way you would normally do it. You have two different scenarios. I have that x minus 5 is less than or equal to 3, or I have the opposite of x minus 5 is less than or equal to 3. All right. Now this one's easy. Okay. If I add 5 to each side, I have x is less than or equal to 8. Okay. But this one, the next scenario is a little different. I have to apply that negative sign to both the x and the negative 5. So now I have the opposite of x plus 5 is less than or equal to 3. Negative x is less than or equal to a negative 2, because I have to subtract 5 from each side. And so now I have x is greater than or equal to a positive 2. And so here's the two things I have to graph. So if I graph them, here's what I end up with. I have an 8 and I have a 2. All right. So up here, I have less than or equal to 8, solid circle, going this direction. And this one, greater than or equal to 2, solid dot, fill it in. And there's my graph. All right. So let's do one more together. Okay. Let's do this one over here. So again, I have to say my two scenarios, and I'm going to do them over here, this side. I say either x plus 7 is greater than 3. Well, let's subtract 7 from each side. I get x is greater than a negative 4. So there's one way to graph it. And then if I keep going, I have the opposite of x plus 7 is greater than 3. And if I continue going normal how I would do it, negative x minus 7 greater than 3, add 7 to each side, negative x is greater than 10. Now I know that my x is less than a negative 10. All right. So here's the other scenario. So let's look at how I would do that graph. Here's my graph. I'm going to have a negative 10, and I'm going to have a negative 4. Okay. For this one, x is greater than negative 4, open circle, arrow that way. For this one, x is less than negative 10, open circle, going that way. All right. There's one other scenario. There's a couple different scenarios that I want you to be aware of. And that's these two right here. All right. Which don't seem that much different.
Whoa.
Okay. That's this one right here. If I solve it, I normally would, I would have the absolute value of x is less than or equal to, so subtract 6 from each side, that would be a -2, right? Is there any way the absolute value of x could be less than a negative number? Because the absolute value always ends up.
No.
Yeah. So the solution, you would say x equals a null set. There's nothing that x can be. That makes sense? There's nothing that x can be. All right? This one is just the opposite. Okay? If I continue to do this one the way I would normally would, I would get x, the absolute value of x is greater than, subtract 6 from each side, I get a
-5.
Okay? Is there anything x cannot be?
5. Or -5.
That would be the only things, wouldn't it? All right? X could almost be anything because it can be any set of real numbers, especially if I said or equal to. Okay? Especially if I said that, there's nothing x can't be. All right? So you would say x is equal to, and you do your little symbol, a set of rational numbers. Okay, it can be anything. All right? So that's how you manipulate those types of equations. Got any questions?
Oliver's here.
Hey, Oliver.
That's not a question. That is a statement.
I know.
Oh, I have a question. Oliver, are you going to be in our math study group thing today?
Probably.
Okay.
All right. Have you guys been using your solution manual that I posted on the classroom?
Yeah.
Okay, good. Is that helpful?
Yeah.
Good.
Yeah.
I'll keep on doing that. All right, guys.